subtopic is finding the probability of an area. Right? Now we have shaded the area. We have found the relevant z-scores. Now we have to find the probability of the shaded area. Right? The first step in this process is reading the probability table. This is the probability table. It's not clear here, but I'll give you a better one later. Now this is the probability table. You can find this in your past papers. Go through the past papers, you can find this probability table. At the exam, you are given this. Right? Now, according to your syllabus, there are two types of probability tables. According to your syllabus, we are using this one, where the probabilities are given from. Here you can see the curve from the middle line. That means Z equals 0. From the middle line to a particular Z value. Right? Then the other type of the table is here, the shaded area is here at the end in one corner. Right? So we are going to use this table. That means all the probabilities are given from the 0 line to a particular Z value. I'll explain that later, right? So we are going to read the probability table. There are two ways that we can read the table. One is finding the probability for a particular z-score. Second one is finding the z-score for a particular probability. Now, where are these z-scores and where are these probabilities? We'll go to this table. In this table, you can see here, this is a column. In this column, you can see some values, right? 0.0, 0.1, 0.2, like that. There are some values. And here also you can see some values. These two together, they are the z-scores. This row and this column and this row, they are z-scores. Now here you can see the formula. Z equals, it's not there, x minus, here it's given mu, that means x bar, right? Population and sample, the difference, divided by SD. Here it's given as sigma. Don't worry about this. The idea is here for both we can get the Z values. And in the probability table you can find there are some probabilities. These are the probabilities. Actually, you know that in this chart, these are the z-scores. And here you can find the probabilities. That means the whole population is represented under this curve. Okay. So the whole population is 1. That's one of the assumptions. And if we divide this is the normal curve has a symmetrical form. That means both sides are equal. And one assumption is that half of the students or 50% of the students are above the average, 50% of the students are below the average. So the whole population is divided into two equal parts, 50%, 50%. Or in other words, 0.5, 0.5. These are the students, the whole population. The students are the probabilities. Remember like that, right? It's the easiest way. These are the probabilities, or these are the students, and here the Z score, right? Now we are taking only one half. You know, this curve has a symmetrical form. That means both sides are equal. We are taking one half and finding the probabilities. So if we take the plus values, here the probabilities are the same. If we take the minus values, there are no minus probabilities, right? Minus plus both are the same here, the probabilities. So we are taking only one half. This half is related to this. Now, as I said earlier, from here we get the Z values, from here we get the probabilities, number of students, right? When you study this closer, you can see all these values are in decimals, in four decimals, right? 0.4332. Likewise in four decimals. And when we consider the Z values, they are in two decimal places. For example, 1.00, 2.25, 2.49. That's why I ask you to calculate the Z score into by getting two decimal values, right? If you have to calculate three decimals and round it up to 2, because in this table you can find only two decimals, right? Here the decimal Z scores, and here the probabilities. Now we'll study this probability table. First, we'll study finding a probability for a particular Z score, right? For a particular Z score, what is the probability? We'll study that. Hope you can see the table now. So we'll find the probability for a particular Z value, right? Now, I told you this is the Z score. Here also it's related, right? How can we read these Z scores? If we study the first one, it is 0.0. Then 0.1, 0.2, like that, 0.9. That means Z equals 0.9. Then you find 1, the whole number. Z equals 1. Then Z equals 1.1, 2, 3, 4, like that. Then Z equals 1.9. Then you can see 2, 2.1, 2.2, 2.4. Then you can find 2.9. 2.9 means that's the highest one. You know, the highest Z score is 3. There are 3 standard deviations above the average X bar. Right? So 2.9 is the maximum you get in according to your syllabus. But now when we studied at the university, we studied that there are 4 standard deviations. So we get other things also. But in your case, it's 2.9. Sometimes in your table, 3 is also there. That is the highest Z score. Right? So here you can find in the Z scores, there's only one decimal place. Right? Now, I told you to get 2 decimal places. How can we read this table? For example, if you take 1 decimal, right? Here, Z equals 1. So, what is the relevant probability? There's only Z equals 1. No 0. Then here you can see all 0, 0.00. So if Z equals 1, then the relevant probability is 0.3413. Okay, 0.13. Z equals 1. If you go to this curve, this is the middle value, Z equals 0, and here Z equals 1. So from the middle line to the particular Z score, what is our particular Z score now? Z equals 1. The probability is 0.3413. Alright. What is the probability for Z equals 2? 2 is here. We are just taking only 2 whole number. Then this is the probability. 0.4772. Likewise. What is the probability for Z equals 0.3? 0.3. Then go to this line, that is 0.1173. Oh, no, it's not clear, right? Go to your table and you can see. By the way, you'll have to have a copy, hard copy. Don't use your phones, right? You need to have a hard copy of this table. Get a printout, or if you have the past papers, you can use these. One thing is you have to get used to this table, because at the exam you are not allowed to use phones, and you are provided with this table. So we'll come back to the lesson. What is the probability for Z equals 0.4? It is this one, 0.1664. Right, that's the way to read. Now tell me, what is the probability for Z equals 1.23? So where's 1.2? Here. 1.2 is here. Sorry. 1.2 is here. Now the question is, what's the probability for Z equals 1.23? Now 2 is there. Use your ruler. Keep your ruler like this. I can't show it here. Keep your ruler like this, 1.2. Then go to this one. Where's 3? 3 is here. Then come down. 1.2. This is the value. What is that? 0.3907. 1.23. 3 is here. What is the probability for Z equals 1.75? So 1.7. Where's 1.7? Here. Use your ruler. Always use the ruler, right? 1.7. Now I said 1.74. So go to this one here. Where's 4? Here. Then come down. And 1.74 here. So what is that value? 1.74. 4 is here now. Because I can't see this clearly. 74. This one. 4591. Right. Likewise, what is the probability for Z equals 2.99? 2.9 is here. Where's 9? Here in this corner. Go down. And 2.99. This corner. This value. Right? That's the way you read the table. Now what is the probability for Z equals 0.25? 0.2. Where's that? Here. 2. Now 5. Where's 5? Here. This is the proof. Likewise, that's the way to get the probabilities for a particular Z score. Now I have given some questions, do them and find the answers, right? Then that's the first one, finding the probability for a particular Z score. We have to find the probability. What are these probabilities? They are the probabilities of the relevant Z scores, right? From the middle line to a particular Z value. Particular Z values are these. Second one is find the Z score for a particular probability. They will give you a probability. Remember mid 30% like that. They will give you a probability, that means number of students and all. And you have to find the Z score, right? They will give the probability, you have to find the Z score. It's easy. Huh? Now tell me what's the probability for 0.3413. There's 3.13. Here you can study. Here, all these are ones, zeros, ones. Then twos, threes, fours. मोनोद में threes, fours की क्या है? 0.43 something. 0.43 something. Here down there higher values, right? Here lower values. So my question is, what is the Z score for probability 0.3413? Where three threes are here. 3413, it's here. What's the Z score then? Z equals 1.0. It's here, no? 0. What is the Z score for 4772? 4772 here. Then it is 2.0. Z equals 2. What is the probability for 0.4726? 4726. Where's 4744? Here. 4726. So what is the Z value? 1.93. Here. 2. Down there. 4726. So 1.92. Right. Next one. 0.1628. What's the Z value? 1628. Ones are up there. So 1628. This one. So what is the Z value? 0.42. Last one. What is the probability for, what is the Z value for probability 4319? 4319. This one. So what is the Z value? 1.49. If there are two equal values, I'll give you two equal values. 0.4985. What is the probability? 4985. Here you can find two values. Two equal values. 4985. So which one you have to take? 2.96 or 2.97. So take the lower one, 2.96. Right? Now the next question is, what is the probability for 0.4379? 4379. Here 4370. Here 4382. 4379 is not there. So how can we find the relevant Z value? There's a different way, right? That's what I'm going to explain now. Right. The question is, what is the Z value relevant to 0.4379? So if you go to this table, we have two values here, but not 4379. 4379 is not there, right? But we have two other values. What are those? On this side we have 0.4370, and here on this side 0.4382. For this 82, what is this value? 4. So for this one, 1.54. 1.54. For this one, 1.53. So which one do you have to take? 53 or 54? How can we decide? Because this value is not there. In this case, you will have to get the difference between these two and these two, and get the least difference. Aduma Venus, least difference. Then that is the particular Z value. Now we'll get the difference here between these two values. Which one is the larger one? Here. So 0.4379 minus 0.4370. Here it is 90000. And if we take this difference between these two values, which one is the larger? This one. 0.4382 minus 0.4379. So here 12 minus 3, 77000. So what is the least difference? Aduma Venus. Aduma. What's the least value? 3. So this is what you have to take, right? This one. That's the Z score. We have the least difference. That means this one is closer to this. So we take this. All right. So what you have to remember now, if a probability is there where you can't find in the probability table, take the two neighboring values and get the differences and find the least difference, and that is the relevant Z value. Okay. And there's another thing I have to highlight. I ask you to calculate two decimal places, right? When you are doing the Z score, Z value, two decimal places. Why? The reason is this. Suppose Z equals X minus X bar divided by SD. This is an example, right? So 78, we'll say X is 78 divided by our X bar, will say 65 divided by SD is 8. So here it is 13 divided by 8. Now I told you to take 3 decimals and round it up to 2. We'll divide this 13 divided by 8. So it is 1, 8, 5, for 50 it is 6. 48 and 2. For 20, it's 2, 16. For 4, then 40, it is 5. Right? So get 3 decimals and round it up to 2. What's the answer? 1.63. 1.63. All right. And the other one, if you take only 2 decimals, what's the answer? 1.62. We'll write it here. Okay. And now we'll get the probabilities. In the calculation, we'll have to get the probabilities now for Z values. What is the probability for 1.63? 63, it is 0.4484. 0.4484. And for 62, 4474. 0.4474. See, you can see a difference. When the probabilities are like this, there's a difference, right? When we find the number of students, how can we find the number of students? We have to multiply this probability by the total number of students, n. Then we can get the proper number, right? The relevant number of students we require. So then we can find different values, different numbers. Okay, that's why we have to get 3 decimals and round it up to 2. All right, those are the things that you'll have to remember. Okay, I have given you some exercises. Do them and practice how to read the table. So when reading the table, they will give you a particular Z value. You have to find the relevant probability. Or they will give you a probability, you have to find the relevant Z values. Right? Both ways. Now we'll find the probabilities for the drawn curves. Right? The same example. Okay. First set of curves. Above 72. Right? Those who got above 72 received prizes. How many prize winners are there? So this is the area we shaded, and I asked you to calculate the Z score. The relevant Z score to this 72 is 2.4. Okay. Now we'll find the probability. In the curve, you can see this side from here, from the middle line, that means Z equals 0. From the middle line to this side, 0.5, right? This whole side 0.5, this side is also 0.5. Now we need to find the probability for this shaded area. There only we find the prize winners, right? Now in the table they give the probability from the middle line to a particular Z value. Now what is the particular Z value here? 2.4. So what is the probability? Go to the table. 2.4 is here. There's no second decimal place, so straight away you can find. It is 0.4918. So you draw a line like this. From the middle line to this 0.2.4, the probability is 0.4918. Okay, so this is the probability for this. Now, is that the probability we need? No, we need the probability for this shaded area. Then what you have to do? You know that from the middle line to this whole section, it's 0.5. And from here to here, it is 4918. So to get the probability of this area, we have to deduct this value from 0.5. We'll do that. 0.5. Since there are 4 decimals, for this one also we'll put 4 decimals, right? And minus 0.4918. So the answer is 0.0082. That is the probability for this shaded area. Now you can write it here, 0.0082, and put an arrow. That's the way to get the probability. That's number 1. Similarly, we can do for this one also, below 46. Right? Here, when you calculate the Z value, it gets a minus value. Minus 2.8. Minus 2.8. So, this is the shaded area. In the table, we get the probabilities from a middle line to a particular Z value. So, in this case, the particular Z value is minus 2.8. But when you go to this section, there are no minus values, only the plus values, positive ones. So, how to get the minus one? So, in the probability table, there are no minus Z values or minus probabilities. Now, since the Z normal curve, normal curve is symmetrical, we take the plus ones, we take the plus probabilities and Z values as the minus values, right? Now here minus 2.8, no, just go to plus 2.8. What's the probability here? 4974. So from here to here, it's 4974. Mark it like this. Then write 0.4974. Put an arrow. Now, is this the probability we need? No, this is the area. So what do you have to do? We know this area. From here to here, we know. And from here to this whole side, it's 0.5. So to get the probability of this shaded area as the above one, we have to deduct this probability from 0.5. 4974. It is 6200. Right, here you can write 0.0026 and put an arrow. Okay, right. Now we'll go to the next one. Here above 49, this is the shaded area, the whole thing, right? So you have to find the probability. As the previous one, we know we have to get the probability of the whole shaded area, right? From here to here, it's 0.5, right? We'll write it 0.5. This side. Now, from here to here, we have to get the probability. You know, from the middle line to a particular Z value, we get the probability. So, what's the particular Z value here? Minus 2.2. So, find the probability for minus 2.2. You know, there are no minus value in the table. So, plus 2.2. 4861. So, you write it here. 0.4861. That is this probability. Now to get the probability of the whole shaded area, we have to add these two values. Then the probability, you can get the probability then. 0.5000 plus 0.4861. The answer is 0.9861. When you do the problem, we have to write the lines. So for the whole shaded area, the probability is 0.9861. We'll go to this one. Below 74, this area. 74 is here. The relevant Z value is 2.8. 2.8. Now, as in the above one, we know from here to here, it is 0.5000. We have to get the probability of this area. From the middle line, Z equals 0 to a particular Z value. What is the particular Z value here? 2.8. So, where's 2.8 here? What's the probability? 4974. 4974. You have to write it, right? And put the arrow. That is from here to here. Then to get the probability of the whole shaded area, we have to add these two together. So 0.5 plus 0.4974. The answer is 4799. 0.9974. That is the answer for this whole shaded area. Okay. This one is little bit tricky, but not that difficult. Once you know the concept, it's easy. Here, between 65 and 70. 65 and 70. The calculated Z values are Z1. Z1 is the furthest one. This is Z1. And this is Z2. Right. Z1 is 2. Z2 is 1. We need the probability of this shaded area. Now what to do? We need the probability of this shaded area. Now, first we'll take the furthest one, Z1. What is the probability relevant to Z1? That is, Z equals 2. From here to here. Draw a line, this space. From here to here, that is Z equals 2. So, what's the probability for Z equals 2? 2. 4772. We'll write it here. 0.4772. Right? And mark it. This is the area. And this area, from here to here, that is the probability relevant to Z equals 1. Right? From the middle line to a particular Z value, here it is 1. So what is the probability for 1? By now you can remember this. 0.3413. 0.3413. Okay. Then mark it. Now, to get this area, we need the shaded, the probability of this shaded area. No? So, from here to here we know. From here to here we know. So what's the, how to get this one? We have to deduct this distance from this distance. Right? What is this distance? 4772. First we'll take the furthest one, that is 0.4772 minus this distance, that is 0. Distance in the sense probability, right? 3413. Right, what's the answer there? 9, 5, 3, 1. So that is the probability of this area. So you can use, or you just write 0.1359 and put an arrow. 1359. Okay. Once you have drawn these things, it's easy. Right, we'll do another one similar to this. Question number 6. Right. Now, how can we do this? The relevant Z values are Z1, that is the furthest one, minus 2.8. Z2 is minus 2.4. Right? So from this middle line to this area, we can find the probability. Why? We know the Z value. What is that? 2.8 minus 2.8. So go to this one and find minus 2.8. It is 4974. This one is 0.4974. What is that? This. Right? Then from here to here, what's the relevant Z score? 2.4. Find the probability for 2.4. It is 4918. 0.4918. That is this. Right? So we have to find this probability. We know from here to here, here to here. So we have to deduct 0.4974 minus 0.4918. So what is the answer? 8, then 6, no, 5, 0, 0. 0058. Is it correct? Yeah. If it is wrong, you get the correct one, right? 0058. So this one is 0.0058. Put that. All right, that is question number 6. Now we'll do question number 7. Right. Here between 50 and 70. The relevant Z scores are here Z1 minus 2 and here it is plus 2. So the shaded area is this. We know as earlier from here to here we can find the probability. Why? The probability is calculated from the middle line to a particular Z value. We know this particular Z value, it is 2. So what's the probability for Z equals 2? It is 4772. 0.4772. Put an arrow. Now here also it is minus 2. Minus 2, the same. Get the plus probability of plus 2. 4772. And here you write 0.4772. Put an arrow. Right? Since my marker is little bit, thick, I can't write it properly, but when you are using your pencils or pens, you can do it nicely. Right? I don't have enough space here. Now we need the probability of the shaded area. We need both probabilities. So we have to add these two together. 0.4772 plus 0.4772. There are no minus probabilities. Right. 4. The answer is 0.9544. That's the probability of the whole shaded area. All right. Actually, we have done the most difficult part now, finding the probabilities. The rest are easy. Okay, right. Now we'll go to the next one, how to get the probabilities of percentages, right? We're going to find the probability of a shaded area when the area is given as a percentage, right? Now we'll see the highest 10% received A passes. What is the cutoff mark for an A? What is given here? Highest 10%. Underline it and then you can draw the curve. So highest 10% here and shade the area. These are the students who got A passes, right? They are here. Now you just write 10%. Okay. Now we have to find the probability. This is what we are doing now, finding the probability of the shaded areas. Now it's given as a percentage. Earlier we had that Z value and from the table we found the probability. But as a percentage. Percentages are probabilities actually. Now we'll see, this is easy, right? 10% means what? 10% means 10 out of 100, right? Now we'll divide this 10 by 100. Yes, nothing. Put it 1. Right? So 10% means 0.1. You know that. That is this, right? 10% means 0.1. But you know that we need 4 decimal places. Why do we need 4 decimal places? In the probability table, the probabilities are given in 4 decimals. Then only we can get the relevant Z value, right? So we have only 1 decimal. We add 3 more zeros, right? So here the probability is 0.1000. Okay, easy. Now I'll tell you, you don't have to divide it like this, right? There's a method, one easy method. We'll find the probabilities when it is given, they are given in percentages. Okay, we'll see. Right. Now we'll take this one. Same. Okay. 10%. Now you know this is the whole number, full number. The decimal point is here. You know that. Though we don't write it, the decimal point is here. Now we take this one as 100% now. As a percentage, 100. There are two, I mean, write 100, there are two zeros, right? So what we are going to do is take this decimal point and take two scallops, 1, 2, right, and put that this thing here, right? So it is now 1, 0. Okay, we need two more decimals, so add two more. It is 10% means 0.1000. Right, we'll do another one. 10% now. 10.1% students were selected for a scholarship, right? 10.1%. So what you have to do? Always take two scallops. 1, 2. And it should be here, no? Here we have taken this decimal mark symbol here. So it's like this. Then we need 4 decimal places at 0. Here also. Okay. Then we'll take another one. 1%. 1% of students are given full scholarships. 1%. How to get this one? Here decimal is here now. So we need to take all this. We need to take two scallops. Put here. And for this one, 0, 1. Okay, we need two more decimals. 0, 0. To make it nice. Okay. We take 0.1%. 0.1% failed the exam. Now 1, 2. For this one, this one, this one, and at another. Why we need 4. Okay. 0.01% failed the exam. Now this one is here, right? So 1, 2 for this. For this. Do we have to add zeros? No. Why? 1, 2, 3, 4. Already it's there. Now we'll do some other common problems. Take usually they give like this now. 2.5%. 2.5%. 2.5% got prices. 2.5 no. So half means what? 2.5%. So 1, 2 for this. 1, 3 we need 4. So add this one. Okay. We'll take another 8%. 8% of students got B passes. 8. So it's here. 1, 2. We need 2 more. 72%. 72% got credit passes. The decimal is here. So 1, 2. And add 2. Okay. Here 0, 0.7200. All right, 50%. 1, 2. Remember 50%? That normal 50%, 50%, 50% above the average. So it is 0.5. Right. 20%. 20%. Quickly. 1, 2. All right. Okay. That's the way, right? 2 scallops. Now we'll go to our problems. Where? Back to our curves. Number 7, we know Z scores are given. No? Number 8, mid 60%, so 30%, 30%, 30%. Here it is 1, 2, 3, 0. Right, so write it here 3, 0, 0, 0. Here also 30% means 0 0.3000. Okay, I'll take another. Right, next one, lowest 15%. 15%. Now I have to do it. Right? 1, 2, 1, 5, 0. Here 0.1500. In front you put that 0. Right here 10%. 0.1000. 10%. Here 4%. 1, 2. For this one, here. This here. 2 more. So 4%. 0.0400. 2%. We did that. 0 to 0. Very untidy. So many 0 point here 0.0200. Right, next one 10%. 0.1000. 5%. 5. So here 1, 2. 0, 5, 0, 0. So that's 5%. 0.0500. All right. That's the way to get the probability. why now not only these shaded areas, we need the others also, because when we calculate the z values and all, later on we are going to do them. We have to find the whole area. Right now you know how to get the probabilities for percentages as well. So what you have to do now, find the probabilities for the first set of data. Right? Find the probabilities of the first set of data, and find the probabilities for the second set of data as well. Right? I ask you to draw the curves one under the other, so you have enough space to calculate these things. All right. Actually, we have completed the most difficult parts